Yeah.
basically, if this is suffix 2 and this is suffix 1, so don't you think that this E should be dropped off? So this shall become what? Bute, ane, 1, ol. Understood or not?
Yeah.
Right? So this is going to be butane 1 ol. Understood.
Yeah. Understood.
Okay. So that's how the name of this complex should have been. So for example, if I give you this structure, for example, if I give you this particular structure and I have a double bond right here and I have OH here. And let's complete the hydrogen CH2, CH2, CH, CH, CH3. So first of all, we have to count the longest chain. So the longest chain is basically 1, 2, 3, 4, 5. So my longest chain consists of 5 carbon atoms. I would mark it as pent. Here in the structure, I see a single bond and a double bond, and a single bond and a single bond, and the double bond gets the preference. So the name shall become pentene. And ene number, whatever it is, I'm going to write down the number later on. And then we have the main functional group, which is OH, which is going to be my alcohol. So it is going to be ol. But the point is that, we have ene also in the structure and we have ol also in the structure. But obviously, I told you that, any functional group, the functional group gets the most preference, followed by
Yeah.
the ine, followed by ene, and least preference is ane. You understand my point? So,
Yeah.
what do you think the numbering? What do you think about the numbering? Is this numbering correct? Is this numbering correct? You tell me.
No, it
This
should
numbering
be the
has to be
other way.
actually done from which this carbon? Carbon 1, 2, 3, 4, 5. So, this red numbering should actually be correct, isn't it? And when this
Yeah.
red numbering is correct, what does that mean? You tell me pent 3. So,
Pent
my blue numbering
3
is of
O.
no importance. Yes. So, it shall become pent 1 ol. And ene is going to start at 3 and end at 4. So, pent 3 ene and 1 ol. And then what am I going to do? I'm going to drop this E. So it is going to be pent 3 in 1 whole. Understood or not?
Yeah.
That should be the name. So similarly, if for example I have this particular structure, so whatever is the number of carbons, I have double bond here and I have OH here. So let's suppose this kind of structure and I'm going to complete the hydrogens. Yes or no? The hydrogen shall be something like this and CH and H and H and H and H3. So let's count the number of carbon atoms. We have one. So where do you think we are supposed to number? From the A end or from the B end? Where
Left
should
to
I
right.
start? From A end. Correct.
Left. Yeah.
Left to right. Correct. So I will be numbering it like this. So 1 and 2 and 3 and 4 and 5 and 6 and 7. So we have 7 carbons. So the word root shall be hept. And the word root should not be hept. The word root should be hepta. Why hepta? Because there is a double bond.
Because two double.
Two
Yeah.
double bonds. And then we know it is ene, but ene is coming two types because for double bond we use the suffix ene. Since there are two suffixes, it would mean what? Diene. So it is going to become heptadiene. And for ol, we would have two ol. Yes or no? And where is this di coming
Yeah.
from? Di is basically starting at 3 and ending at 4. That is my first ene. And 1 is starting at 5 and ending at 6. So it is going to become 5 comma 6. So that shall be the name of this complex. Are you understanding? Because all
Yeah.
we are using for OH. Are you understanding? That's the point.
Wait, why is it 5, 6? Isn't it
Oh,
3
sorry.
and 5?
3 comma 5. Sorry. 3 comma 5. 3 comma 5. Hepta 3 comma 5 diene. And this E has to be dropped because there is an O in the next suffix. So I told you that, if one suffix 1 ends with E, And suffix 2 has a, ain, een, ein. The suffix 2 is starting with a, e, I, o, u, y. A,
Yeah.
E, I, O, U, Y. So this E has to be dropped. You understand my point?
Yeah.
Okay, so that is the concept. That is the concept. Okay, so similarly, for example, I give you this structure. So we have the carbon chain and I have COOH. So basically, I am giving you this open chain structure. Yes or no? But the point is, the structure you
Yeah.
would be given like this: CCC COOH. So it shall be something like this. But I am giving you this open chain structure right here. So COOH write down, can write it down like this. Or COOH, you can write it down like this. You are showing the bonds right here, isn't it? COOH, you can show like this, or you can show it like this. Both of them are exactly the same thing. You understand? So here, what are we going to do? Just
Yeah.
understand. Here, what are we going to do? We're going to say COOH. It doesn't matter. But here, COOH is my functional group and it is a carboxylic acid. So, what is a carboxylic acid? I'm telling you. Carboxylic acid is a chemical which is found in mostly fruits and vegetables. You understand? So, when it is found in most of the fruits and vegetables, what does that mean? It means that, this chemically, you will always find this COOH group in it. Always. Like, for example, you must have heard that, tea consists of tannic acid, isn't it? Lemon consists of citric acid,
Because
right? You must also be knowing that, apple consists of malic acid. So, all these acids that you're talking about, it consists of some acid in it. And by nature, these are all edible acids. And these edible acids are basically going to be carboxylic acids. Are you understanding? These are going to
yeah.
be carboxylic acids. I hope you're understanding my point. So here, what do you think we're going to do?
Yeah.
Just tell me here what is going to happen. So here we have to count that carbon which consists of the carboxylic group. So I'm going to put it like this. So it is going to be 1 and 2 and 3 and 4. So 4 carbons, bute. Single bonds between every carbon, single bond, single. Can you see the cursor? So butane. Yes or no?
Yeah.
Can you see the cursor? Can you see the dot that is coming up?
I can't. I can't see the person.
Okay. Now can you see the cursor?
Yeah. Yeah. Yeah.
Okay. Okay. So this shall be what? This shall be butane, single bond. This is also single bond. This is also single bond. This one. So if this is single bond,
Yeah.
single bond, single bond. So butane. Yes or no? And thereby butane and then at one carbon, oic. Because oic is the suffix when you see COOH. So it shall become butanoic acid. Understood or not?
Do we remove the E, right?
And we are supposed to remove the E. So you don't write
Okay.
down one because one generally doesn't matter. So we can straight away write down butanoic acid. And the common name for butanoic acid is what? Butyric acid. The common name for butanoic acid is going to be butyric acid. Are you understanding?
Yeah.
Okay, so this is how this is going to be. Understood or not?
Yeah.
Right? Now, for example, if I have this structure, so then this could be same structure. COOH remains COOH. One second. You switch on the video?
What?
Yeah, better.
No, I had my video on.
Yes, yes, yes. Fine. So now let's suppose we have a double bond here and a triple bond here. It doesn't matter what double bond or triple bond we have. So we have CH and H and H2. So it is going to become what? It is going to become 1 and 2 and 3 and 4 and 5 and 6. So 6 carbons we have. So that shall become hex. Okay, that shall become hex. Understood? And single bond we have. So it shall become 1 and 2 and double bond. So because we can see a ene as well and an ine as well. So now forget about the functional group for some time because functional group definitely is important. So that is definitely going to come at the end. So oic acid is the suffix which is going to definitely come at last because that's my functional group. But now let's choose between ene and ine. Ene and ine, who is going to be more preferable? Ine. So ine
I,
comes here and then ene comes just before that. Let's copy down the numbers. So oic acid, do you understand? And ene is coming at number 3 and ine is coming at number 5. And now we drop the E for ene and E for wine because obviously just after one suffix ene we had y and just after ine we had oic. Are you understanding my point?
yeah,
Any doubts in this?
no,
Okay. So if it is going to be, so it is going to be hex 3 ene, 5 ine, oic acid. Understood or not?
yeah,
Yes or no? So that's the name of the complex. And then there could be side chains. So the rule basically remains the same now. So nothing extra is there in the naming part now. Just it's like you have to identify the functional group and use its own suffix. So let me give you a few more examples like this. For example, if I have this compound. Now what functional group do you see this is of? This is of aldehyde group. This is an aldehyde group. Are you understanding? So if this is an aldehyde group,
yeah.
what do you think it is going to happen? Just tell me. What do you think it is going to happen? Just see.
It will be kept at the end
Exactly.
and
So
al.
al shall be suffixed at the end. So 1, 2, 3, 4, and I could write it down CHO as well. But I hope you're understanding. Either you write down CHO or you write down like this, open chain structure,
Yeah,
or like this. It is still the aldehyde. Don't get confused between aldehyde and carboxylic acid. Carboxylic acid is 2H, 2O, and aldehyde has just one. You
yeah,
understand my point? Okay.
yeah.
So, how would you name this complex? Just tell me. It shall become 1 and 2 and 3 and 4.
Butanal.
Butanal. So, 4 carbons but, single bonds ane. Drop the E, 1 al. We don't have to write down 1. So, it is going to become butanal. Understood?
Yeah,
Hmm? Okay. Now, have a look here. Then, the kind of compounds we have. So, what is this? CH3, C double bond O, CH3. Just have a look here. What do you think we have? One, two, three. So the carbons are 3. So it shall become prop. 3 carbons propane. But you see C double bond O and R here and a R dash here. So it is going to be my ketone. Okay. So don't you see 2 alkyl groups right here? One is methyl and one is methyl right here. So methyl C double bond
yeah,
O CH3. Are you understanding my point?
yeah,
Understood? So methyl C double bond O CH3. That is going to be the 2 alkyl groups on the left hand side and right hand side, marked by the red color here, and one CO group in the between. That is called as a ketonic group. Are you understanding my point?
yeah.
Any doubts in this?
No,
Okay. So what do you think we have it right here? The name should be propanone because obviously it is a ketone group. So ketone has a suffix on. Yes or no? So that shall become propanone and drop the E.
Yeah.
So it is going to become propane, and by one it should be two. Propane 2-one because it is a second carbon. And the common name for propanone is acetone. Do you understand my point?
Yeah.
Any doubts in this?
No.
Okay. So that is how you name it. So for example, if I give you few more examples, it shall look something like this. So carbon, 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 and a double bond O, and CH3, and CH2, and CH3. How do you think you will name it? Tell me. So it is 1 and 2 and 3 and 4. So word root is but.
Bute
Hmm.
2
Hmm.
and then O.
Butane. Ane has to be there. Ane, E9 will always come
Yeah.
first, followed by the functional group suffix.
Yeah.
You understand? Followed by
Mm.
the functional group
Butane
suffix.
2.
Exactly. So it is
Yeah.
going to become butane to one. And then they drop the E. So it becomes butane to one. Understood or not?
Yeah.
Any doubts in this?
No.
Okay. So that's the concept. That's the concept. Are you understanding my point?
Yeah.
Now have a look here. So for example, if I have this particular part like this. So we have CH3, CH2, CH2, and CH3. How would you name this complex? Tell me. Tell me.
Pentane 3 on.
Correct. So it shall be pent for the five carbons and pentane, ane for because there is a single bond between the carbons, and we
Previous
have
factor.
three one, and you drop this E. So what do you get? Pentane 3 one. Understood or not?
Yeah.
And now, for example, now this would be the last concept. Nothing a concept like now I can just give you one compound COOH. Would you be able to name this complex? So how many carbons? So you can see COOH group right here. So this is the functional group, so that gets the preference. So it is very clear. I have to number it from 1, 2, 3, 4, 5, 6. So the carbons are 6, so word root shall become hex. And ANE9 shall always come first. So what do you think I should put in? There is a AN, but a EN. So I'm going to put hex EN. And EN comes at number 2. So hex 2 EN. And 1 oic acid. So E drops. This much we have numbered. So basically we have numbered the main chain and the functional group we have numbered. Yes or no? Understood or not?
Yeah.
And then we are going to name rest of the things. They're all going to be my side chains now. So here, fluoro is there, chloro is there, bromo is there, nitro is there, methyl is there. So obviously bromo comes first because alphabetically bromo has to come first. Then bromo, A, B, C, then chloro,
Fluoro.
then D, fluoro, right? So bromo, chloro, fluoro, and methyl and nitro. A, B, C, D, E, F, G, L, M, N, M. So then methyl and then nitro. And just put in the numbers. So we have bromo shall be what? Bromo shall be 4 bromo. Chloro shall be what? 3 chloro. Fluoro shall be what? 2 fluoro. Methyl shall be what? 5 methyl. And nitro shall be 5 nitro. That's the name of the complex. So first name the main chain and the functional group, and in the blue you write down all the prefixes in the alphabetical order. Did you understand the basic theme of the nomenclature, Ayush?